Hi, it's Mr. Adams from Midwood High School. This is a brief video on electron dot structures for an atom, neutral atom. The dot structures are simply a nice shorthand way to represent valence electrons, okay? And the symbol itself, all right, represents the kernel. Now, what's a kernel? We did this before, right? The kernel simply is everything else except the valence electrons. Remember, valence electrons are the electrons found on the outermost principal energy level of an atom. And typically, the sides of the symbol represent orbitals. So here we have one s orbital right here, and we know from experience there's three p's. Remembering the 1, 3, 5, 7 rule, right, for orbitals. So s always has one, and there's 3 for p. So there's 3 p's over here. There's 3 sides right here left. All right. Now, what would happen, for example, if you had to do the dot structure for magnesium? You would simply look on your reference table, right? And you'll see magnesium has a electron configuration of 2-8-2, right? And you know these are your valence electrons. So you from that need simply 2 dots. Now, typically, we know that S's have lower energy than P's, so we'll start at S's, where the S is, and we'll place 2 dots there, and you're done. Okay, so that will be the dot structure for magnesium. And the Mg symbol represents the kernel. Now, if you had lithium, you'll simply look at the configuration again, and you'll see lithium's configuration is 2-1, right? So you will simply put 1 dot up here, okay, in the S location, okay, and you're done. All right, so lithium has 1 valence electron, it gets 1 dot. For xenon, okay, if you notice on your periodic tables again, because you're looking at your periodic tables, xenon will have 8 valence electrons. Now, for our purposes, guys, we cannot go over 8 valence electrons, so you'll simply put 8 dots around xenon, okay? You'll get 8 dots. Okay, that's xenon. And for nitrogen, okay, if you look once again on your periodic table, you see nitrogen would be 2-5, right? Where 5 valence electrons. So if it's 2-5 with 5 valence electrons, you just simply have to put 5 dots around this N right here. So you just put 2 here, okay, for the S, okay, and 1, 1, 1. It's following Hund's rule, okay, where you're sharing out the electrons as much as possible. That's 5, and you're done. Now, a word of warning: you may see in some textbooks or some other teachers, they don't really put a big premium on where do you put the dots, as long as you have the correct number. Now, it depends on the teacher and the textbook. Some folks don't mind where you put them. For example, if you start, for example, I've seen in textbooks where aluminum, which has 3 valence electrons, has 2 dots here and 1 over there, right? But just be careful. This convention, following the S and the P's, you can go wrong with it. But just be careful that you may see some textbooks not following the this exact way. But make sure you have the correct number of dots, okay, and you should be fine. So I've seen also aluminum represented as 1 here, 1 here, 1 there, actually. So, but people have been given credit for it. So once again, you should follow this convention, okay, first, right? But it depends on your teacher and the other textbook that you may be reading. As always, hard work plus sacrifice equals success. Okay, remember, know your definition of valence electrons, know your definition of kernels. Okay, the dots represent the valence electrons, and you should be fine with it. Take care.